I think people are just all coming in, which is great. Awesome. So welcome everyone. We'll get started in probably around 1 minute or so. We will encourage you to, I think if you look at the chat, we encourage to put in any questions you might have in the Q&A section there, rather than in the chat. We'll have a short session at the end of the webinar to answer those Q&A questions. And we'll try to get started. So, great. Hi, Pam. I just saw your chat. All good. So it's just myself, Alan here. I'm from Northmore Gordon, and my colleague Patrick, who is from Northmore Gordon Environmental. So we come from the same group, and yeah, we'll be delivering this webinar here. So this is series 1 of our webinar series of introduction to carbon credits and certificates with measurement verification. And in this series 1, which is today, we're going to talk about New South Wales Energy Savings Scheme. There will be 2 other sessions next week, and yeah, we'll cover that in the later series. All right, we'll just get started. Okay, so what we'll cover today, so will be a short session to talk about a bit of government programs overview. So we'll mainly talk about VICs, SKIs, and ACUs with just one single slide. There will be then a focus on New South Wales energy saving schemes. We'll have an overview of the methods that's currently available under the scheme. We'll have a focus on project impact assessment with measurement verification, which is a MMV-based methodology. There's another one called meter baseline, which will be covering that as well. And also there is the deemed methodology, which is called installation of high efficiency appliances for businesses. It is something that is suited to smaller size projects, but we'll cover that with some case studies. So we'll have a few case studies about the projects we've done so far, and some of the project size and minimum threshold guide, and follow up with a Q&A session at the end. So yeah, just a quick introduction of Northmore Gordon. We provide strategic energy sourcing procurement to large industrial and commercial customers. We provide certificate grants, independent MMV, which will cover certificates in this series. So in this series here, and we'll also have provide corporate decarbonization roadmap strategy to our customers. Well, there's also technical services, which is a traditional consulting service that we provide in terms of auditing, energy auditing, some of the feasibility studies, etc. All right, so meet the team. So as you guys probably saw in the link that when you register, I'm a principal consultant at Northmore Gordon, and I cover mainly MMV projects for the business. Whereas Patrick Blaine, who's my colleague here from Northmore Gordon Environmental, covers pretty much all certificates, including deemed certificates as well. So he will be covering some of the deemed slides for you guys a bit later in the series. I'll let Patrick jump in.
Thank you, Alan, and thank you for the introduction. Welcome, everybody. So give you a quick overview of Northmore Gordon and where we've come from and where we are today. So Northmore Gordon was founded in 2009 by our directors, coming from a background in energy efficiency and with a drive to fighting climate change through a variety of methods, but mainly focusing on energy efficiency as one of our core services, and the business has grown from there. Around 2013, we started our first M&V project under the New South Wales ESS, our first M&V project, and we've grown from there into the Federal Emission Reduction Fund to create ACUs, and further increased our capability through 2017, 2019 through the purchase of BCW, a consultancy in Newcastle, and the purchase of a division of National Carbon Bank, the Energy Integrity Services, which include their M&V projects, to bring in personnel and additional expertise in this area and consolidate our experience in the measurement and verification space. So we've grown today. We've got measurement and verification projects across Victoria, New South Wales, and nationally under the Emission Reduction Fund. And we currently have 1.5 million certificates under development. There's a number of drivers really for undertaking these kind of projects and accessing the government funding and the government incentives that are available. Now, efficiency activities have been traditionally brought on potentially from finance, from site, from headquarters targets, and they're usually about driving bottom line savings from a financial perspective. But there are another, which is really important, but it has drawn a number of other benefits to businesses who want to undertake these efficiency activities and capitalise on the government incentives available. It goes on to the continuous improvement of the site activities. So there's often a lot of plant that might be either too large or too small as site requirements change. Risk reduction for reducing maintenance downtime, upgrading site assets as plant gets older. And we're seeing more recently that a carbon neutral strategy and carbon strategies are becoming a greater focus for participation in these programs, which are usually driven from headquarters around corporate sustainability goals. One of the key takeaways from all this is accessing environmental certificates enables the carbon saving, the value from that, which as a result of your energy efficiency upgrade, to be monetized, which you can then use to offset the capital cost of your projects. Understanding these efficiency projects can be quite capital intensive. Using these government programs really does help with that, and it gives you another pathway to capitalise on the environmental value, where in other ways it's maybe difficult to do that beyond the sort of the sustainability goals, but then we can actually translate that into some dollars to help fund these projects for you. So in the Australian landscape, there's two types of programs. There's the market-based programs and the direct action programs. Northmore Gordon, we participate in both of these. So the main one we're talking today is the New South Wales Energy Savings Scheme, which is a market-based program. There's also the Victorian Energy Upgrades Program and the Federal Renewable Energy Target. These market-based programs all work in a similar way, where the government puts an obligation onto energy retailers to surrender a certain number of certificates each year, and then allows activities to be undertaken to generate these activities. There'll be accredited providers, such as ourselves, that can create these certificates from energy saving activities. There's an audit process, there's compliance paperwork that has to go through. Once these certificates are generated, they can be sold to energy retailers, who then take those certificates at the end of the year and surrender them back to the government. And when those certificates are sold, that enables us to monetize that value and pass that value back to customers to pay for those upgrades. In contrast, the Emission Reduction Fund, or the Climate Solution Fund, you may have heard it termed, is legislation under the Carbon Farming Initiative. And this is the federal government's sort of direct action approach, you may have heard, where the government buys ACCUs directly in the primary market. So once a project's been approved, similar, you go through the compliance activities, generate certificates. The government then buys those certificates directly and uses them towards things like meeting our obligations under the Kyoto Protocol and potentially under the Paris Agreement going forward. So that's sort of more direct action, where the government will buy the carbon savings. Now, these are talk about, I guess, the primary markets for all of these certificates. In some cases, there are secondary voluntary markets for some of these. So LGCs, there is a voluntary market for LGCs to offset power use by sites, electricity use by sites. And similarly, there's voluntary markets for ACCU surrender to offset businesses' carbon emissions. Now, under these programs, there's, I guess, two key types of activities. We'll talk about deemed activities and measurement verification. So today we'll be focusing mostly on the measurement verification side, but it's good to understand that all these activities, all these methods do include deemed activities. which you might be more familiar with if you've participated in the ESS or the VEU programs previously. The deemed activities are predefined savings calculations. So for a particular type of upgrade, commercial lighting is maybe a popular one where for certain types of lights are awarded a certain energy saving and over a certain period of time. The methodologies tend to be simpler, based on defined calculations of easily obtainable parameters on the equipment being upgraded. The compliance time and the time to collect all the evidence is faster, so it means the payment from the end of the upgrade to when you get the money from the certificates can be a lot quicker. They do tend to be a bit more conservative in their approach in two respects. One, that the formulas are calculated to be a little bit conservative, so not over creating certificates, and also tend to be averaged out across the state. So, on average for a particular activity across New South Wales, for example, the energy savings will be about right, but any one upgrade might be awarded more or fewer certificates than they otherwise might be entitled to. These kind of deemed approaches are probably better suited for small to medium-size upgrades in terms of energy savings achieved. And some of the activities that you might be familiar with or might be appropriate for gas boiler upgrades, chiller installation, lighting upgrades, and refrigeration. Contrast that with a measurement and verification approach, which allows any technology, so there's no predefined methods or activities that are acceptable. And what that means is you can use any type of technology as long as you can demonstrate that energy savings have been achieved. Now, to do that, there is a more complex analysis that's required. And because of that, there's a bit more of a higher upfront cost, and there's a longer time, which can be up to 12 months to measure and verify the savings have been achieved, which depends on the type of project that you're undertaking. Which that means, you can be looking at 12 to 18 months after the commissioning of the upgrade before the money from the certificates is available. Some of the benefits of this is that you actually get the actual energy savings are quantified and can be credited, as opposed to the deemed approach, which maybe takes a more conservative option. And these type of projects are better suited where there's a larger energy saving.
Thanks, Patrick. So yeah, I'm just realized, just wondering, if you have any questions, feel free to put in the Q&A panel, and we can cover that at the end of the session here. So what is measurement verification? So it's an international recognized standard which is used for quantifying and verifying energy, water, or carbon savings. So the reason for this is because, for example, you could have a site that operate 4 or 5 days a week, producing maybe 1,000 packs of coffee beans or coffee pods each week, during the baseline, in this case, before you do the project. But suddenly the demand increased so dramatically, and such as what we've seen during the COVID, everyone stays at home and they want to buy more coffee pods rather than going out, buying coffee. So coffee pod demand goes through the roof, and those coffee factories now roast beans, 24/7 or at least 7 days a week. And in that regard, if you just purely, compare your baseline or an operating period, for example, if you commissioned your project just before COVID, then your operating period, even though that your per kilogram of coffee pods being produced, the energy consumption has actually decreased, but your operating period might actually see a surge of energy consumption. That doesn't really mean there's no saving achieved, and that's why measurement verification is important. So in this case, you can see the example on the right-hand side. This is just one of the ways that we can quantify or verify the savings. So we build a model for the baseline energy consumption, based on side inputs such as production or weather variables, and based on that model, we then adjust your operating condition as if operating period as if it's still during the baseline production level. So in this case, we call it adjusted baseline methodology, and you can see that in between the dot points and this actual post-retrofit, which is operating period, that's your verified saving. So this way, the savings is actually verified and quantifiable. So we take all that routine adjustment and non-routine adjustment into consideration. So that gives you a statistically valid quantification of energy saving that's being achieved. So that's just one way of doing MMV. So there are many different ways that we can model the savings, which will cover the modeling techniques a bit later in this webinar series. All right, so give you a bit of overview of the New South Wales Energy Saving Scheme. So the objective from the New South Wales ESS is to reduce energy use in New South Wales, and it's not directly linked to carbon reduction, even though there is a energy conversion factor, which is sort of similar to a emission factor, but it's not. So it's really important that we understand that. This is the only scheme in Australia that's based on energy reduction, whereas the VEU, which we're going to cover next week, and the ERF, which we're going to cover next week as well, are both based on emission reduction. So the target is based on a percentage reduction of the total electricity usage in New South Wales. In 2021, this year, it's the target's 8.5%. Which is approximately 4.6 million ESCs that needs to be created in 2021, which is the target. Now, the electricity supply amendment, which is for the energy saving regulation 2020 from the New South Wales government, has already been finalized, and they are having an ambitious target for the increase of the percentage reduction of total electricity usage per year from 2021 to 2030. In 2030, the target will increase to 13%. So that's one of the drivers that's pushing the ESC price going up. So in the past 12 months, ESC price, energy saving certificate price, has been traded between 24 to 31. But I think at this very moment, the price is high, so it's roughly around 30.4. Around that, and there's because of the ambitious target set, there's potentially a increase of the ESC price over the long term. Okay, so let's talk through the methodologies, or we call it activities, under the New South Wales ESS. We'll cover PIMV and middle baseline today with some comparable case studies from the deemed methodology as well. So starting from the project impact assessment with MMV, it is an MMV methodology. It allows you to forecast your energy savings for 10 years discounted, depending on the project, or depend on the equipment. There will be a decay factor we have to apply. So it could be anywhere between, you can create up to 5 to 6 years, or up to 10 years, in total. So that gives you funding, a bit earlier. And you still have to wait for the measurement verification to complete, but it will give you 10 years of savings, which will translate to funding, ESC's funding for you, which will improve your financial for the project. Now, the New South Wales ESS does not allow fuel switch right now, except if it's between natural gas and electricity. So you could burn more natural gas and going through a generator and create electricity. The electricity get consumed on site. So in this case, you use more natural gas and consumes less electricity from the grid. In this case, it's allowed. So you draw a boundary around the site, and you can then say, okay, this is there's a increase of natural gas we have to measurement boundary. But because you reduce electricity consumption, there's potentially ESCs available for that project, but it's not really a lot. We'll cover that at the end, but there's a current consultation from the New South Wales government, which is trying to introduce fuel switch methodologies under the scheme, which will potentially allow fuel switch between renewables, natural gas, or between renewables and electricity. So it could be solar, could be biomass, could be biogas, could be waste to energy as well. And we'll also quickly talk about meter baseline methodology, which is it's also MMV method, but it only allows you to do annual creation for 10 years. So it's normally on site level boundary, but it could be flexible. If the site is really big, you could have a certain production on the certain warehouses or certain factories. You treat that as a boundary for meter baseline. That's still acceptable. Now, the advantage obviously the disadvantage for meter baseline is that you cannot forward create. So you must do annual reports for 10 years. But the advantage is that you can start with a foundation project. You can claim annual improvements. With non-ECMs, for example, you could have a large project that replace the boiler system at your site, which gives you a lot of savings, and that could be the foundation project. But over the years, you could have fixed compressed air leakage, or you could have fixed you could have done some simple control projects in the boiler, in the refrigeration side of things, which will also be covered in the meter baseline project. There's also the deemed, which is the installation of high efficiency appliances for business, which Patrick just mentioned earlier. So we'll have some case study for that as well, just to compare the certificates and timeline between MMV and deemed methodology. There's also public lighting, commercial lighting. Again, if you've already been exposed to VEU or ESS in the past, you should be pretty familiar with the lighting projects, which has been the focus over the last 5-6 years. Okay, so a typical project steps. So we go through certain steps to make sure that the project's eligible for SKI creation down the track. There is, before you implement or commission the project, there's a nomination form that has to be signed between the energy saver or the project developer and us, which is the accredited person in this case. So there will be some training requirements, and we'll have to create a baseline model, which is part of the measurement verification plan. Now, there's a new requirement under the rule where your measurement verification plan needs to be approved by a measurement verification professional on the ESS panel, which is a third party, before you implement the project. So once the project's implemented, then we'll start the evidence collection process, and also the start of the monitoring of the normal operating period. So the operating period cannot start until your site, after your project's commission, you have to wait till your site is under normal operation. So that's the start of the operating period. Depending on the model that we've done in the baseline. So if your model is depending on weather, so it has a seasonality, so you produce, you use more electricity or use more natural gas during a certain time of the year, which means there's some sort of seasonality in the site, around the site. Then which is mainly because you use boilers or use cooling. There's cooling demand, HVAC, etc. When you have a weather variable that needs to be introduced. If that's the case, the operating period, so the monitoring of the operating period has to be a full 12-month period. But if the project's not really related to weather, you could have a operating period that's as little as 1 month, for example. So once we've done operating period monitoring, we do an operating model. So there's certain analysis we have to do going through the modeling process. And we then write up the measurement verification report that has to go through an MVP, which is measurement verification professional, and then going through the audit with a third party before you can create certificates. So if it's a project or site or measurement boundary that covers some sort of weather or variable as an independent variable, or there's some sort of seasonality in the energy consumption pattern, we're realistically looking at between 16 to 18 months between the commissioning of the project and the final S-key creation. All right, so let's talk through some case study, which is the exciting part. So yeah, we've done a chiller and water heat upgrade in a shopping center in New South Wales, just outside of Sydney. And they installed 2 1-megawatt water-cooled chillers and with new cooling coils, replaced electric duct heaters with a reverse cycle heat pump. So there's no natural gas consumption on site, which is good because in this case, there's no sort of interactive effect if we just draw a boundary around electricity. So the measurement boundary is the whole site because there's only electricity consumption at the shopping center. We used PIMV, which is the forward creation methodology with a forward create for 10 years. The energy model was quite straightforward. So this project sort of completed before COVID. So everything was very standard, normal on the site. So the site operates 7 days a week, etc. And there's that's obviously there's the peak hours, off-peak hours, but it's very consistent with how many people are going through to the shopping center. So we built an energy model, a good energy model based on energy versus weather variable. In this case, will be the cooling degree days and heating degree days, which are pretty much the weather variable in this regard. The saving was verified to be measured and verified to be 180 megawatt hours per annual, and the net payment to the customers was at the time was around 31,800 plus GST. And because it's a project with that has correlation with weather, we had to do a full 12 months monitoring period, and for that project going through audit, review, etc. It took a total of 18 months after when the project's commissioned. All right, Patrick might want to talk about the comparable deemed chiller installation.
Yeah, thanks, Alan. So for a similar upgrade for this one, had it been done under the deemed method for chillers, it would have been a slightly lower return, about $19,000 on a comparable S-key price, but the payday would have been much faster, about 2 to 3 months after the commissioning of the system. There's a couple of reasons for this. So it's a much simpler methodology. Being a deemed method, there's a preset calculation. It's based on the GEMS registration for products. So there is a GEMS category for chillers. They have to go through the efficiency testing requirements to be registered under the GEMS register. So that means there's easily accessible and verified data on their energy performance. The regulators are able to use to come up with a simple formula. So that basically means for a particular water-cooled 1 megawatt chiller, there is a certain number of S-keys or energy saving certificates that will be created. They normally assume a forward life of 10 years as well. So similar to the PIMV, essentially forward creating 10 years. There's a much simpler evidence requirement because all you really need to show is that a particular chiller of a particular make and model was installed. And then you get credited the S-keys based on that. That means the audit compliance requirements are a lot simpler, so we can go through that process a lot quicker.
Thanks, Patrick. So just a quick summary of that. So if you just quickly compare the payments, so 32,000 compared to 19, so like double the amount if you do a measurement verification, but you're going to have to wait for 18 months rather than 2 months in this case, which depends on what's the priority for your project, I guess, or in your certain circumstances. All right, so that's that. So we've also done some data center UPS upgrade. So there's a UPS upgrade at data center I think in the CBD of Sydney CBD. So the data center only covers 1 floor of an entire office building. So they sort of share the cooling tower on top of the office. So we did a measurement boundary for the NIMI just around that floor, which exclude the cooling tower. And because of that, the electricity consumption has a very low correlation with weather. So energy consumption has been very consistent over the past year when we look at the MMV plan. So we used an energy model called estimate of the mean. And because of that simpler process, we could actually wrap up the entire project within 5 months after project's commission. So that includes 1.5 months of monitoring for the operating period, which is all estimate of the mean approach, and going through audit, review, etc. So the net payment to customer was 105K to customer. Savings was still quite decent in this case, was 522 megawatt hours per annum. Being a data center, it really depends on how old the data center is. So there's some certain things we have to look out for. So across the board, we see data center upgrades as in fan upgrade, UPS upgrade, simple things like control upgrade, still gives you a decent amount of savings. All right, there's another case study here, which is a console pool boiler replacement. So they replaced the 470 kilowatt conventional boiler and replaced that with the new condensing boilers. So in this case, it's not a fuel switch. It's purely just replacing with a more efficient unit. We set a measurement boundary on the site, natural gas import meter, and we use PIMV for creation of 10 years as well. So the energy model in this case was, because it's a console pool, it's really, and because you have to heat those water to a certain degree, which is not that high, but still you have to heat it. It has correlation with weather, and it also has some bit of correlation with operating hours of the center. So it depends on how long they operate the center. They have to run the boiler for a longer period of the day within the day, which will get them to consume more natural gas. So the saving in this case with a more efficient unit, with two more efficient units, was 5,250 gigajoule per annum, and the net payment to customer was roughly around 98K plus GST. And again, this was a project or a site that has correlation with weather. So we had to do a 12-month monitoring period for the normal operating period after when the project is commissioned. So the total time spent was still around, I think this case was 17 months to 18 months. Then there's the comparable for a deemed installation.
Yeah, thanks, Alan. So again, similar deemed upgrade for a similar type of upgrade, two boilers being replaced, replacing two conventional boilers, using a deemed boiler replacement methodology. There's a much smaller payback, only about $7,000. Again, a much shorter payback time. So what's that compared to, Alan, for the M&V approach for payback? So much smaller payback, looking at 10% in this case. And that really varies. It depends on the type of boiler you're installing. The way the methodologies work is they assume you're replacing a sort of an industry standard boiler of a certain age. So it doesn't take into account the actual baseline so much, baseline efficiency or the new boiler efficiency. It takes much more industry standard. So it tends to be a lot more conservative than what you might actually achieve, which is verified through the M&V approach.
Yeah, that's correct. So in this case, I assume that in this case, the conventional boilers here in console pool was really old, and that's why the savings was much more than the industrial standard. And of course, there's certain disadvantage of being a more conservative approach with the deemed methodology, which gives you less certificates. In this case, resulting into less net payment to the customer. But again, you don't have to wait for 18 months for the project to finish. You simply have to wait for 2 months, which is just some paperwork. There's no measurement verification required with the deemed methodology. So we'll also talk through some industrial case studies. We complete this project, which is a biogas to package boiler heat recovery project, very earlier in the days, I think back in 2018. So basically, there's a wastewater treatment plant on site, and the project was to there's already a biogas capture and flaring of biogas at the moment, and the project was to divert the biogas, remove certain impurities out of it and co-fire with the natural gas boiler. With natural gas boiler in the packaged boilers. And because the existing biogas was already flared in the baseline, the project was really considered as heat recovery from the flare to the boiler rather than fuel switch. So if you think about it, you draw a boundary including the wastewater treatment plant and biogas being flared, which is heat being lost. So you recover those lost heat and direct biogas into an existing boiler system. And in this case, it's not really considered as fuel switch. I mean, it could, but we argued that it's really heat recovery. So we set a measurement boundary to all fuel intake into the package boiler and also including the methane flow meter as well at the flare point and also at the boiler. So with biogas sending to the boiler flow meter. So we use the meter baseline approach for annual creation of 10 years because there are some certain projects that they want to take in the future years, such as control project with the packaged boilers, which will be making the boiler system more efficient. The engine model was based on natural gas consumption versus production out of the site. I wouldn't want to disclose what products they produce, but you could, in this case, we just find this simpler, and because they don't have a steam meter on site, so you could have a engine model between natural gas versus steam production as well. The savings was measured and verified to be 67,000 gigajoule gas per annum and credited annually for 10 years, and net payment to customers was 127,000 per annum for 10 years, which is quite substantial. One thing we haven't really covered, which it's going to be a bit difficult for you guys to understand at this stage, but if you do a comparison between how much certificates you can claim in New South Wales scheme versus the VEU schemes and the EIF scheme, New South Wales scheme is very generous on giving you certificates for the same amount of natural gas savings. In this case, I think it's double the amount. So basically, in New South Wales, a similar project will create double the amount of certificates compared to the same project in Victoria or anywhere else in Australia. So that's sort of a bit of drive for a natural gas reduction project in New South Wales, which gives you more rebates in a way. All right, so there's also the case study for kiln advanced processing control upgrade. So in this case, it was they call it APC project, but it's really a control project on the mud feed and fuel flow to maintain the excess oxygen, which is being sent to the burner system. So it resulting in the result was a better product quality. So there's less residue from the kiln system, and it saves natural gas because there's better control in place. So we set a boundary. In this case, it's a massive site, massive industrial site, but we set a smaller boundary just around the kiln, and the boundary was just the natural gas intake at the kiln. So in this case, it was quite straightforward because they did not have any other fuel intake into the kiln. We used PIMV for flow creation of 10 years. The engine model was natural gas versus production out of the kiln, and the savings were quite substantial. We were 326,000 gigajoule of gas being saved, and net payment to the customer was 620,000 plus GST. And because it's a kiln system, the temperature, the burner temperature at the burner tip is really, really high. We're talking about 1,000 degrees Celsius. So it has very, very low correlation with weather variables. And we didn't have to do a 12-month operating, monitoring period for the operating condition. In this case, we used about 3.5 months of monitoring for the operating period, compare that with the baseline, and chosen a normal year in 2019, and the payday was roughly around 8 months between when the project was commissioned and the payday. There's a minimum threshold guide here, which is really something that we think that's going to be a minimum saving that needs to be achieved, so that we make the measurement verification approach achievable, but obviously discuss with us if you think your project will be eligible, and we're happy to give you guys an estimate of the certificates. Now with the deemed methodology and lighting projects, there's really no minimum threshold. So talk to us about that and we can give you an estimate.
All right, thanks, Alan. I guess we're running a little bit long on time here. So I think just to give us some time for some questions, we might jump across to those. Might pick first question off the rank, which actually came to from Peter regarding what information do you need about the project to determine if the deemed or M&V method would create more ESCs, which kind of relates back to the minimum thresholds you just went through, Alan. Do you want to jump in and answer that one?
Yeah, sure. So hi, Peter. So the project, depending on the savings, if as we probably mentioned earlier, if the savings is large, I mean, there's always a number associated with it. But if the savings is big, we're talking about more than 200 megawatt hours saving for PI&V, or more than 500 megawatt hour saving in meter baseline. If that's the case, then we deem that as a large energy saving project, and we would think that the M&V methodology will suit the project better. But there are many other variables we have to consider. For example, if the site may be a new site, so you don't have enough baseline data, so we can't really build a model for the baseline, so measurement verification doesn't really work, then deemed methodology will be your only choice. Now, in terms of, let's assume everything, the project is eligible for both methodologies, we will need, some information about the project, what the project is, if it's a chiller project or if it's a control project, what sort of upgrades you're looking at, what sort of saving you are anticipating, and that's I guess that's all we need. So we'll then look at those things and give you an estimate of the certificates, and we can even do a comparison with the dollar amount between the two approach, and choose the one that suits you the best.
All right, thanks, Alan. Got a question from an anonymous here. If LGCs are generated for a solar system, which represents greenhouse gas savings to be made over the life of the system and then sold, does that mean we have effectively sold the carbon savings to someone else and can no longer claim the electricity generated by the panels is carbon-free when we use the on-site generation? Or can we sell the LGCs and still claim that we are generating the green electricity? I might pick up that one. That's a bit more of a deemed related question, but yeah, that's correct. So the certificates essentially hold the environmental value of those, that energy generation. Once it's sort of sent out, it just goes into the grid. So it goes into the pool with gas generation and coal generation and hydro generation and wind generation as well. So there's no really way to tell if that's green anymore. The greenness of that electricity is in the LGCs. So if you've sold those LGCs, you're effectively selling the right to those carbon savings, which are then either bought by the retailers or bought by other companies for voluntary surrender. So let's just have a look at the greenhouse carbon accounting standards, the national greenhouse accounts. They'll give you some guidance on how to deal with LGCs, but typically you need to have the LGCs to claim the green credentials of that electricity. I've got one final question here from Chandana. Is power factor correction covered in the ESS? Can you please confirm?
I don't think so at the moment. So, purely just from measurement verification point of view, we can only measure and verify actual savings, so the real energy savings. So if it's a power factor correction, it's really saving reactive energy. So it's not something that we can cover in the measurement verification approach. Now, whether or not ESS would like to introduce a methodology to cover power factor correction, we don't know yet. But as far as we are aware, there's no methodology that currently looks after power factor correction in New South Wales scheme.
I've got one final question just snuck in there. What about ESCs from voltage optimization?
Good question. So yeah, we've seen different views on this. So I personally, I know my mentor had completed measurement verification on a voltage optimization project in the past, and there were actual savings being measured and verified in that regard. I think it really depends on the end user. So what's the equipment that's being voltage optimized? We have done one project in the past, and we've done measurement verification for a period of time for that voltage optimization project, and there was just no savings. I think they were anticipating maybe 100 to 200 megawatt of savings a year, but we measured and verified and found out what there was six megawatt hour saving a year. So it was really close to zero. So I think it's not a question I can answer straight away. It really depends on what the end equipment is. And there's possibility that there's actual saving that's being achieved, and as long as it can be measured and verified, the saving will be there.
All right, thanks, Alan. Well, thank you everyone for joining us today. I hope you've got something out of it. We have 2 more sessions coming up next week. One will be focusing on the Victorian Energy Upgrades Program on Wednesday, same time, 3 p.m. And again on Friday next week at 3 p.m. Focusing on the federal or nationwide emission reduction fund projects and opportunities. So thank you very much for joining us today. We hope you enjoy the rest of your week.
Yep, and contact us if you need any help. That's my contact details and Patrick's. We'll look forward to seeing you in the second and third session of the series.